All right, so this is a picture of a solar panel where we have water that's sent through and cool water sent through, and then as the light hits the solar panel, it heats up the water, and then the water goes back through, and it's a continual cycle as it goes around. And this is solar panels are easily mixed up with solar cells, which are different. Here's another picture here, sunlight coming in, being absorbed, and then warm water being sent out. Here's another picture here. And, so yeah, solar cells, on the other hand, transfer light into electricity. So it's a conversion of light into electricity there. And you can see some solar cells. Geothermal is another way to generate electricity. You're taking the hot water up through the pipes and then sending it to the power plant. It heats up steam turns the turbine turns the generator, and you get electricity coming out, and then you send that cooler water back down through the Earth's crust, back down. So it's kind of sad, we're only getting about 25% power out of our engine's practical power. The engine itself is not very efficient, and so we're dealing with, and this is an example of Sankey diagram, the kind of purpose of this, where with the Sankey diagram, everything is to scale, and that's what we see in this picture, where all of the things, all of the arrows, this is the 30%, 40%, 5, and 25, they're all, proportional. This is 1/4 of the whole width of, the 100% here, and we got that. All right, now one of the things that's critical in this unit too is looking at efficiency, what you get out of or what you put in, and this is very helpful because quite often, we need this to be able to determine, maybe how much fuel we need or to evaluate a system, and so so this can be very helpful here. So let's go ahead and try this with this engine. It's 23% efficient. And we want to know if the energy and density of gas is 40,000 joules per kilogram. In other words, if you have 1 kilogram of gasoline, and you burn it, and it turns into energy, that energy would add up to be 40,000 joules. And go ahead and pause the clip. And actually, let me give you the question first. How many kilograms would we need if we wanted to get out of this engine 160,000 joules of practical energy out of this engine? Now, we know that if it was 100% efficient, all we would need is just 4 kilograms, because that would be 4 times 100, or 4 times 40,000, and we would get it out. But this is going to need a lot more kilograms of gas to make that happen, because the efficiency is only 23%. So go ahead and pause the clip and give this a try, and when you're ready to check, you can hit play to continue. Okay, so the efficiency is 23%. We want to get out 160,000, so what do we need to put in? We need to put in a lot more than that, and so we've got that here. Now, how many kilograms will that be? Well, 40,000 divided by that net value, we're going to need 17.4 kilograms, much more than just 4 kilograms, right? If it was 100% efficient.